Alright, good afternoon, gentlemen. Here we go again. Excuse me, I went through the HA8-8 manual, Org Zero card, and performed the modifications to the CPU card using wire wrap fly wires as detailed in the manual. And I was wrong about some of the ROM stuff. The Org Zero mod for the disk controller, which isn't even in the machine right now, simply disables the entire ROM on that card, and then all of the ROM code goes onto the CPU card. So some of the modifications to the CPU card enable it to work with a 4K ROM instead of just a 2K ROM. So I knew that the 28-pin adapter that I had put on the disk controller card was working because we were able to successfully run the memory tests on both the system memory and the controller memory off of that ROM when it was installed on that card, when everything was in factory stock mode rather than Org Zero mode. So since that ROM is not necessary on that card in Org Zero mode, I desoldered the adapter that I'd made since I was sure that it was working as it was supposed to, and I put it on the CPU card, which made me sad. I had to get rid of that nice white vintage socket, but they've got these ridges on them, see, and I couldn't plug a socket into the socket to make it work. There just wasn't enough room, so it had to go. And of course, you know, sockets in that day weren't as beefy as sockets today, a little more heat sensitive. A couple of the pins got left behind on the board when the socket came off, which was kind of a shame, but c'est la vie. I'll just have to deal with it. So I performed all of those modifications on the CPU card, and now when I try to start the machine, and I've verified that the ROM is good too. It's not the ROM. You'll see that there's a pin broken off of this ROM, but that pin on the 2864 is actually like no connection. It's just that's where the 5-volt supply came from for the 24-pin ROMs. So I broke the pin off just in case it was used for something internally, and we were supposed to leave it floating. I didn't want it connected to 5 volts since it was listed as no connection on the data sheet, you know what I'm saying? So it's still a perfectly good, 28C64 ROM there. So it should work. This is the same ROM that I was using in the disk controller. But when I turn the machine on, the power and run lights on the console come up, but the monitor doesn't actually run. I must have missed a step or something. Well, I know I missed some of the testing steps because I was being a dork and hurrying through and didn't perform all of the tests on the Org Zero cards that I should have. But I had thought to myself, well, it's a simple card. What could go wrong? I did some. Now this card goes in the backplane backwards. If you plug it in forwards, it'll blow up, like literally. That's what had happened to this card when I got it. Something had blown up, I can't remember what, and I had to replace some stuff on it. But I went through and I pulled all of the ICs off of the card, because, I mean, it's a simple card. There's these things that look like diodes. Those are actually ceramic capacitors. There's nothing, those are all just bypass capacitors. Other than that, it's nothing but a 5-volt regulator and some resistors. The regulator's working fine. There's 5 volts on the card. I pulled each of the ICs and tested them in my TL866, and two of them, well, one of them was marginal. It worked sometimes, and it tested bad other times, and one of them was bad. I think the LS240 was bad, maybe an LS04 or something. I can't remember anymore. But so I replaced those. I had to use a 74 HCT 240 instead of an LS240 there. So hopefully it's got enough fan out to drive everything. Hopefully that's not what the problem is. I don't have any actual LS240s, I don't think. You know what, I need to look through look through some of my other spare parts boxes. I'll bet I do have some actual LS240s somewhere. But anyway, so I figured, you know, that's an easy way to test this. I didn't try to actually, you know, like poke in like port stuff to switch the banking on and off from the front panel before I modified the CPU card into Org Zero mode, which was a mistake because obviously something is wrong. I have a sneaking suspicion, look out there, capacitor, that the problem is actually something to do with this memory card. I configured it into, Org Zero mode, or what I assume is Org Zero mode from the manual. That's everything turned on and the ROM bank disabled jumper set. I don't know, this card's always been a little funny. It's only got 16K on it at the bottom of the memory map, so when you're using it in non-Org Zero mode, only 8K of that first bank is available, starting at 8K, because the ROMs exist in the lower 8K, right? I mean, I'm not casting aspersions at any of the newly manufactured cards. I've got one of Norberto's 8080 RAM boards here that I could build and use in the machine, but I'm really keen on trying to make this thing work with as much actual old hardware as possible, you know what I mean? That's why I'm so insistent on messing with this stupid board. I've been told that this particular board is a problem sometimes. It's got its own refresh circuitry, and the refresh circuitry gets weird or something like that. It passed all of the RAM tests though, so I think this particular problem isn't with that. But I don't know, I may have to just build out Norberto's card just to see what happens. I guess it's possible that the XCON 8 ROM tries to use more than 8K of RAM, but if that were the case, that would screw things up as well. I need to do a little more reading on that, I guess. To use the H17 definitely requires more RAM than 8K. So, but some of the tests that it talks about doing for the Org Zero board talk about using an 8K RAM card just for testing purposes. Hey, look, it's not backwards. So this is a fairly poor scan, photograph actually, I guess, of the schematic for that DG dynamic RAM card that we've been fighting with, and up here is the ROM disable signal and the jumper which enables and disables it, and it's interesting to note that this card is driving the ROM disable signal rather than reading it. My assumption was that the card needed to watch the ROM disable signal so it knew when to not decode the lower 8K of RAM. What apparently happens is that when the CPU accesses the ROM, it doesn't actually drive the bus normally when it's accessing the lower 8K, and what the ROM disable signal does is it tells the CPU card to access the bus instead of the ROM when it accesses the lower 8K. So I had this jumper set because I assumed that the RAM card was reading ROM disable instead of driving it. And so it was probably contending with the ROM disable signal that the Org Zero card was trying to drive. So if one of them was low and one of them was high at some point, it could very well have blown up this flip-flop or the one on the Org Zero card, and that might explain why I had a couple of bad ICs on that card that I had to replace, the line driver, and it wasn't the flip-flop, it was an inverter, but I'll bet that inverter sits somewhere, I don't know. I don't want to speculate on that. But that would explain why that chip was screwed. So I've got the ROM disable signal on this board disabled now. The board should still work with CPM, Heath CPM. GG had their own version of CPM, which is, I assume, and their own monitor ROM. And they called it the FP8 monitor ROM, but it requires a Z80 apparently. I was going to burn one and put it in here and see what happened, but it came with their Z80 CPU card that they also made, so I'm figuring it's probably got Z80 opcodes in it. It's not going to work on the 8080 card, right? So that's not something to try. But with the ROM disable signal just disabled on the RAM card and retesting the ICs on this thing, maybe that's what the problem's been the entire time. I hope. I shall return once I test some chips here. If I did blow up the flip-flop on the DG memory board, it probably doesn't matter, because I'm not using the ROM disable signal on that thing anyway, unless it also blew up some other flip-flops. That is going to be U22. I will also check it in case. That's probably going to be a dual flip-flop. So the other flip-flop in that chip, it's probably a 7474 is my guess. But the other flip-flop in that chip is probably used here somewhere else. So if it blew up, but yeah, here's the other one down here on on some of the primary decoding logic. So if it blew up both of those, it may have made the card unusable. Yeah, I'll test that U22 as well. It seems like I may have finally gotten over the stupids at least a little bit and maybe figured something out. I guess we will see. I'm a little suspicious of some kind of funny business here. This is the assembly manual for the ORG0 card. It details the modifications that need to be made to the CPU card in order for it to work in ORG0 mode. This is the 8080 CPU card. So it's got us getting rid of some old jumpers here. This all has to, most of it has to do with the ROM. And then installing some new jumpers here, and here, and installing these two fly wires. This fly wire here connects T2 to plus 5 volts, and this longer fly wire here connects S2 to an address line. I don't remember off the top of my head which one. Here is a schematic of the modification that I obtained in the same archive as this assembly manual, and it matches the drawing here. And when it says to connect these fly wires here, it just says connect and solder one end of the wire to hole T2, connect and solder the other end of the wire to the indicated circuit board foil right here. So this is the only source of what goes to where other than this schematic that I can find. This schematic may have been drawn from this picture. I don't know. Anyway, this is the ROM. These are all of those jumpers, most of those jumpers that we were talking about before in this picture. Alright? Now if we look at this, yes, it is connecting pin 18 through S2 up to A11 on the CPU. Okay, and on the other side, it's connecting pin 21, which is through hole T2 to plus 5 volts. Now, if we look at the, first of all, Mr. Cat, your claws are sharp. Please get them out of my leg. If we look at the 28C64 pin out here, alongside the, crap, where is it? Did I not bring it over? Oh, duh, I need to, I'm a retard. I don't even know how to operate the computer. Ridiculous. Alright, so here's the 2732 pinout. And we want to compare it to the 28C64 pinout, because the way that we modify this board to work with the 28-pin RAM, because I don't have any 2732s to program, and I don't think they ever made a 28C32. They made a 28C16, but I don't think, maybe they did, but if they did, I'm not going to buy any more, because I've got a billion 28C64s. So the way you make a 28C64 work in this 24-pin socket is the pinout of the 28C64, the lower part of it here, aside from these top 4 pins, is basically the same as the 24-pin thing here. You got all the same address lines, the same data lines, the same ground down this side, ignoring these top 2 pins, and down this other side, ignoring these top 2 pins. What would normally be VCC on the 2732 is now non-connected on the 2864, and all of the rest of the lines going down the side are exactly the same. They call them something different, but this is chip enable down here, and this is output enable up here on pin 20. Also, when you raise this to like 24 volts on pin 20, that's how you program the 2732. That's why it's got this programming voltage next to it here. So the way that you make the 28-pin ROM work in the 24-pin socket is you tie this not connected pin here up through write enable, so that write enable is not floating, and up to VCC to provide power to the chip. You leave pin 1 unconnected because it's an output of some kind, and you either allow pin 2 to float and put 2 copies of the same ROM in there, so that whatever 812 happens to float to results in the same value. You can concatenate two 4K ROMs together to make an 8K ROM and put into this thing, and just ignore whatever 812 is. It doesn't matter if it floats high or floats low, because it's going to pull the correct value out, because there are 2 copies of it in the ROM. What I did was I went ahead and just tied it to VCC, so it's always looking in the top part of the ROM. But that doesn't matter. You can install a switch on there on the back of the computer to switch 812 between plus 5 volts and ground if you wanted to have 2 different ROM images that you wanted to select between on boot. And I may do that at some point. I don't know. That's a bridge to jump off of once we get everything else working. Now, here's the interesting part. Here is the interesting part. Let's go back to the 2732 pinout, since we've already shown that a 28C64 can work fine in a 2732 socket, as long as we make this little adapter with these top 4 pins here. Alright, here's a 2732 pinout. Let's go back to our schematic, which we already showed matches this drawing. It's a little easier to follow the schematic. We're looking at pin 18 here of the 2732 ROM. It is tied to A11. If we look at the pinout of the 2732 ROM, pin 18 is the chip enable signal. That's a little weird. Here's where it gets even weirder. If we look at the schematic again, pin 21, that's supposed to be the chip enable / programming voltage, is tied to plus 5 volts, which is a little funny. But anyway, if we look at pin 21 on the 2732, that is A11, alright, and it's tied to plus 5 volts on the schematic. This is exceptionally strange. I don't understand what's going on here. With A11 tied to plus 5 volts, you're only ever going to access part of this ROM, and it's not even like the upper half or the lower half of this ROM, right? Well, yeah, it is. I was thinking A12 was the low. I can't do math in my head. So that's weird. That basically turns 2732 into 2716. You're only using half of the ROM, and then the chip enable is tied to the A11 address line. I think this is a misprint in the assembly manual, and these fly wires are supposed to be reversed. I think S2 is supposed to be tied high, and T2 is supposed to be A11 is supposed to go to A11 on the CPU. But if the chip enable is tied high, the chip will never get enabled, which is also pretty weird. You'd think you would tie chip enable low, you would tie A11 on the ROM to A11 on the CPU, and then all of this stuff, whether the ROM outputs or not, is gated by this ROM enable over here. Alright, which decodes the ROM disable, it decodes, this goes down to the read line. You can see that in the actual, like the big schematic before the modifications. It goes down here to the mem read line, okay? So this decodes all the addresses for the ROM, the mem read for the ROM, and whether ROM disable has been asserted by the ORG0 card or not. So this decodes everything in the ROM and determines whether it outputs or not. Alright, so this ought to be just tied low, so that the chip is always enabled. The chip's output is gated by this decoding over here, and A11 is tied to A11 like it's supposed to be instead of the chip enabled. I don't understand what is going on here. This is very, very strange. And if any of you can hit me with a clue stick, I would really appreciate it. Pin 21, it says right there, pin 21 connects to T2. And pin 21 is A11. A11 is permanently tied high on this ROM. So there's no way to ever read the lower half of the ROM. It makes no sense. It has to be a misprint. And I've tried reversing these two wires, these two fly wires, and the system still won't boot to the monitor. I have not, however, tried grounding the chip enable on pin 18 instead of tying it to plus 5 volts. But this modification with the ORG0 card has to have been something that a lot of people did to their H8s. And you would think that if there was an error in this manual, that I would have heard about it by now, and that these manuals that I downloaded from, like, the main site for getting stuff for the Heathkit computers, would have had corrected manuals in it. But I don't know, maybe everybody uses a Z80 card now that bothers, to run CPM. And this slipped through. I don't know. Clue me in, guys. I'm too stupid to figure this out. Alright, we got progress here. We got progress here, gentlemen. Here's a table of ROM chips. It turns out that the XCON 8 ROM was actually a 2532 ROM, not a 2732. And if we look down this column here, chip enable and A11 are indeed reversed on the 2532 versus the 2732. Also, this table is incorrect in saying that pin 21 on the 2532 is a low chip enable. That must, I haven't looked at the data sheet, but it must actually be a high chip enable signal, and then you raise the voltage on up to like 25 to program or something like that. Or maybe it's not even a chip enable. Maybe it's just a programming pin like on the 2716 and shouldn't be tied low or anything. In any case, let me switch back to the overhead camera. Alright, power's off. Yes, okay, good. Let me pull this out and show you. I removed the fly wire from S2 up to plus 5 volts, and instead I tied it to ground. S2 to S3 ties that pin to ground. And then I reinstalled the CPU card and tried to boot with the DG RAM card, and it failed to boot. But then I, being suspicious of the DG RAM card, took my shitty perf board RAM card and modified it to work in org 0 mode by not decoding the lower 8K anymore, instead decoding all 64K with a piece of capacitor lead, piece of bypass capacitor lead, and bending that IC out of there, and that did it. It fired right up. So things are good. I still want to see if I can figure out how to make this card work with it. I'm not sure why it isn't. I've got it set up with it's ignoring ROM disable, and it's got all of the memory on the card enabled. I'm not sure why it doesn't want to boot with this card. But that is an investigation for another day. I am going to play some SSI games on a Heathkit PC and have a fun rest of the evening. Let's see, tomorrow there may not be a video. I have a lot of side work to catch up on tomorrow, like legitimate side work. I may fart around with this a little bit late in the evening, but there probably won't be anything tomorrow. So see you on Tuesday evening, I suspect, unless I get home from the... I don't know what to call side work and what to call real work now. I'm still doing my software development side gig that I did when I was farming, but I'm helping a buddy of mine with his construction business too, doing some electrical stuff and just general grunt work and stuff like that. You know, a good excuse to get out of the house and hang out and, you know, kind of just doing it for fun. The pay's not terrible, but it's not. It gets me out of the house. You know what I'm saying? But I don't know which to call side work and which to call real work anymore. They're both kind of the same. Weird. Anyway, I digress. See you next time.